Welcome to the video for C5.13, choosing a reaction pathway. So before you start your previous knowledge, you need to look back at the last lesson, which was on atom economy and percentage yield, because we're going to use these factors to help us decide which reaction pathway. So you need to understand what they are first. So our learning objectives for today, you need to be able to state some factors that are considered when we're choosing a reaction pathway, and then use information about different reaction pathways to evaluate which pathway is best. So before we start, we need to know what a reaction pathway actually is. So a reaction pathway is either a reaction or sometimes a series of reactions that you use to make a particular substance. So when you want to make a chemical, quite often there's more than one way that you can make it. And you need to decide what the best way to make that chemical is. And in order to do that, you're going to have to take in a whole range of different information. So this lesson's about what information you need to consider and then some practice considering that information. So what factors are important when we're choosing a reaction pathway? Now, some of these we've come across before and some of them we haven't. So you need to copy this down into your notes. So the things we need to consider are, we need to consider what the reactants are. So the reactants are our starter material, sometimes called the reagents. They're the chemicals that we are going to turn into our products. So in terms of our reactants, we need to think about how much they cost, because obviously the cheaper the better, because then we can make more profit if we're using a chemical that's cheap. We also need to consider whether they're renewable or not, because if we're going to do something long term and we're going to do large amounts of it, then if something's not renewable, then it's going to cause problems because it's going to become in short supply and it's going to become more expensive. And lastly, whether the reactants are toxic or hazardous. So we try to avoid using things that are toxic, and we try to avoid things that have hazards such as flammability, because it means those chemicals are more difficult to use safely, and there's always cost associated with doing things safely. So apart from the reactants, we need to consider the efficiency of the reaction. So in the last lesson, we talked about percentage yield and we talked about atom economy. So both of those two factors are important in deciding which reaction pathway we're going to use. We also need to think about the energy we're going to need. So if a reaction's done at a high temperature, so say a reaction's done at something like 2000 degrees C, then that's going to take a lot more energy than something that's done at kind of 100 degrees C. And there's two problems with energy. First of all, it costs a lot, and secondly, a lot of the energy that we generate is generated from fossil fuels, which not only are running out because they're non-renewable, but also have a lot of pollution associated with them. So when we burn fossil fuels, we tend to make carbon dioxide, which is a greenhouse gas. So we also need to consider our byproducts. So when we make a reaction, we have our main product, which is what we're trying to make, and then sometimes we have one or two other products that are also made, and we call them the byproducts. So things we need to consider about these are whether they, just like the reactants, whether they're toxic or hazardous, because if I've made something and I'm not going to use it and it's toxic or hazardous, and it's going to cost me more to get rid of it, it's going to be more difficult to get rid of it. Also to consider is, can we find a use for them? Because as we talked about atom economy, if we can find a use for the byproduct, then actually we can improve our atom economy and make that a much more viable reaction pathway. We also need to consider the rate of reaction. So if reactions are fast, we'll make lots of product in a short space of time, which is obviously desirable. If a reaction is slow and we can't speed it up by adding a catalyst or changing the conditions, then we're going to make less product in the same time and we're not going to make as much profit. But we'll talk about rate of reaction in C5.2. If the reaction is reversible, which we'll look at in C5.3, then we need to consider what the position of equilibrium is, so whether it's on the left-hand side or the right-hand side. So we would want the position of equilibrium to be on the right-hand side because that would give us more products. But this won't make sense yet because we haven't done C5.3, so we'll revisit it when we get to reversible reactions. So the best way to have a look at choosing a reaction pathway is to look at an example. So we're going to take an example here. So there's a chemical called ethene. It's an important chemical. It's used to make polythene. It's used to make polyvinyl chloride. It's used as a building block in a lot of industrial chemicals. And we can make it in one of two ways. We can make it from ethanol, which is then dehydrated, so it gives ethene plus water. And then decane can be cracked to make ethene. Now, the cracking of hydrocarbons will be dealt with in a later lesson in more detail, so we cover that in C6. So we don't need to know all the details for now, but it will become important later. So here are our two methods. So if we take ethanol, so a dehydration reaction is when you remove water from a molecule. So it gives us our ethene, which is what we want, and it gives us water. And I've written the simple equation there as well, so you can see it. And then for cracking, if we take decane and we crack that, then we get ethene and, oh, sorry, that says decane. It shouldn't be decane. It should be octane. So we've got two methods here to make our ethene, and we want to know which one's best. So we need to consider all the things that were on the previous slide. So we need to look at the reactants, we need to look at the efficiency, we need to look at the energy, we need to look at the byproducts, and we need to look at the rate. So if we look at the reactants, then for dehydration, so ethanol is reasonably cheap, and you can make ethanol by fermentation of biomass. So you can grow crops and then convert them into ethanol. So that means it's renewable, because once you've removed the crops and converted them into ethanol, you can grow some more crops. So you've got a continual supply of your ethanol. By comparison, cracking, so decane comes from crude oil, which is non-renewable. So once that's been used up, there won't be any more, because even though crude oil is made continually, it's made at such a small rate compared to how quickly we're using it up. So it's effectively non-renewable. In terms of efficiency, so I couldn't find figures for percentage yield for these two reactions, so we're going to have to just look at the atom economy. So if you work out the atom economy, and it'd be good for you to, from the balanced equations there, have a go at working that out and confirming for yourself that for the dehydration it's 61%, and for the cracking it's only 20%. So in terms of the efficiency, the ethanol is better. Now in terms of energy, dehydration is carried out at 170 degrees C, and cracking is carried out at 150 degrees C. So much more energy is needed for the cracking. So it's going to cost you more. You're going to produce more pollution. So again, the ethanol is better from that example. In terms of byproduct, so the dehydration of ethanol just makes you water. Now, water is a great byproduct to have, because not only is it non-toxic, it's easy to dispose of if you want to get rid of it, but it also has many uses. So it's used as a solvent in a lot of industrial processes. So it could well be just kept and used in another industrial process. Cracking is the byproduct is also good, because unlike what it says in the equation, you get octane as your byproduct. And octane, you may have heard that word before, is one of the alkanes that we use. It's used in petrol. So obviously there's a big demand for that. So by using that octane, we can take the atom economy of 20% and actually take it to 100%, because both ethene and decane have got uses. So our atom economy is not really 20%, it's more like 100%. In terms of rate, so dehydration is kind of medium speed reaction, cracking is fast reaction. So for that one, cracking is the best. So if we just highlight the best of those, you'll get this table here. So you can see in 4 of the categories, the ethanol is better. However, 3 of the ones, ethanol is better, because the byproducts, both of them are pretty good. But the atom economy, as we said, because you've got a use for the byproduct. So there's not really a clear winner, but if I was going to say which one was best, I would say dehydration, because it's renewable and cheap, and it's less energy needed for its temperature. Now, it's important, so you don't need to learn these specific details for this reaction or for any reactions. You will need to look at making ethanol, but that's covered in a later lesson, so we don't need to worry about that now. So what I want you to do now is have a look at this second example yourself. So if we want to make aspirin, there are two methods. There's method 1, which is taking ethanol chloride and hydroxybenzoic acid, and that makes aspirin and hydrochloric acid. And then we can take, again, 2-hydroxybenzoic acid, but instead of reacting with ethanol chloride, we can react it with ethanoic anhydride, and that again makes aspirin, but it makes ethanoic acid. So I want you to pause the video now, and there's 6 statements there about method 1 and method 2. So you've got to work out, based on that statement, which is the better method. So, for example, I'll talk you through the first one. Ethanoic anhydride is cheaper than ethanol chloride. So ethanoic anhydride is the cheapest, that's the best one, that's used in method 2. So for that one, we would say method 2 is better. And then once you've done that, use those statements to decide which method you would rather use. Would you rather use method 1 or would you rather use method 2? So once you've done that, so you need to pause the video, carry that task out, and then unpause the video and look at the answers on the next slide. Right, so hopefully we got that the better method for the first statement was 2, because ethanoic anhydride is cheaper. Then ethanoic anhydride is safer to use than ethanol chloride because it's less corrosive, so that would also indicate that 2 would be good. Hydrogen chloride is dangerous, it's corrosive and poisonous, gives poisonous fumes off. So hydrochloric acid is a byproduct in method 1, so that means method 2 is going to be better. The reaction between ethanoic anhydride is a lot slower than the reaction between ethanol chloride. So the ethanol chloride one is better in terms of rate. So method 1 would be better for that. HCl can be sold for a reasonable profit. So if we can sell the HCl, that makes our atom economy 100%. So method 1 would be better than that. And lastly, ethanoic chloride is more easily hydrolyzed, so its reaction with water is slower. So we don't want it to react with water, we want it to react with a hydroxybenzoic acid. So method 2 would be better from that point of view, because the ethanol chloride might go off by reacting with the water, you'll get a side reaction. Right, so overall you can see 1, 2, 3, 4 of those indicate that 2 is the better method and only 2 indicate 1. So we're going to go with 2 is the better method. Now, having said that, I've just looked at that. This doesn't contradict that 2 is the better method, but we said on there HCl can be sold for a reasonable profit. Now, you might recognise the byproducts in method 2 as well. So ethanoic acid is vinegar. It's sometimes called acetic acid. It's its old-fashioned name. So that is actually used industrially as well. So you would be able to sell that, but HCl, I believe, would give you a better profit than the ethanoic acid. So overall, we're going to say that 2 is the best method. Right, what we need to do now, this is a proper exam question. So this is a 6-mark question where you need to evaluate the advantages and disadvantages of the 2 methods for making ethanol. So I want you to pause the video, have a go at it, make sure you consider the raw materials, the type of process, the rate of reaction, the conditions used, the purity of product, and the atom economy. So using all the information in that table. And then once you've finished it, unpause the video and have a go marking it using the mark scheme on the next slide. Okay, so these are all the points that you could have made that are worth some credit. Now, the easiest thing to do with marking the 6 marks is to actually print this off or write these out and then tick what you have, compare it with your answer and tick off what you have said. And then that allows you to see what you've missed off. Now, it's not as simple as one tick gets you 1 mark. To work out how many marks you've got, we need to look at the next slide. So pause this video and work out what you've written that is mark worthy and highlight that, and then we'll go into the next slide. Right, so in order to get 5 to 6 marks, you need to have had at least 1 advantage and 1 disadvantage of each process, and you needed to have identified the better process. If you've to get 3 or 4 marks, you needed to discuss at least 1 advantage and at least 1 disadvantage, or give 2 comments about each process.